Fire. In case you weren't here, he's the developer of Cydia, which is the alternative to the App Store for jailbroken iPhones, and he's the creator of Cycript, which is a runtime introspective debugging REPL, which is a hybrid of Objective-C and JavaScript. Jay Freeman.
Can you hear me now? My God, that was loud, actually. Need to talk softer. Okay, so yes, my talk actually didn't even have a title listed until yesterday. There were like a couple different talks that maybe I would be doing, and there were some coordination issues getting that all figured out. But with the, I didn't even understand. It was like it's a short amount of time that I have, and then with some of the things that Apple announced at WWDC, I clearly know what I'm going to be doing about what I'm talking about today. So actually, I need to send script.deb 272.20.10.3. Worked, good. Okay, so what I do is, I do a lot of things as she described. The thing that I often end up doing demos of at conferences is this thing called Cycript. So Cycript is a JavaScript console. So just like, I can say function return 3, 4, var, y is equal to that. It has syntax highlighting, it has tab completion, and most importantly, it has a bridge to Objective-C. So if I say NS object, I can allocate an NS object. I can send it things. This is going to return the exact same thing I just had. Send things like description. I can use Objective-C syntax for constructing things like arrays. I can then use the syntax from JavaScript in order to manipulate these arrays. So this actually, I had an Objective-C array that contained 4 and 5. I just sliced it into a JavaScript array that contains an Objective-C 4. Now I can send that JavaScript array object at index 0 as an Objective-C method, and I get back the 4. So I've kind of blurred the object models between Objective-C and JavaScript. So my experience then, while watching the WWDC keynote, as doing all this, is whoa, they just added a objecting console to apps, and that was like one of my #1 features that I like showing people. So the thing I very quickly noticed, though, is that the using Swift, they don't have very good tab completion on anything, and so you're trying to introspect into things. It's very difficult to actually utilize it. And so, by the way, yes, I just mentioned something about Swift. Why am I allowed to mention something about Swift? I actually have this little preview thing up that specifically states, in this new agreement, you will not be bound by the foregoing confidentiality terms for technical information about pre-release Apple software and services disclosed at WWDC. I can't show you the actual tools. I cannot show you screenshots or give you my opinions on whether I like it's really awesome or really horrible or anything. But I can totally tell you what it is and how it affects me and how it affects you. And though, really great, they released an app, the WWDC app, which actually uses Swift inside of it. And that app is public. Anyone can download that app. You can't log into the app unless you have a developer account, but everyone has the app. Cycript allows me to introspect on said app, which means that I can actually now go and use Cycript on that app, and then we can start learning more about Swift and what it does, how it works, etc. I also have the WWDC app open right now in Hopper, which is a disassembler that you can get from the Mac App Store. And I've annotated a few of the data structures that I'm going to be messing with. So this is my phone I've SSH'd into. I just installed the new version of Cycript that will hopefully crash less on dealing with this thing. And one thing I really should have done before doing this is verify that this is actually, thank God, okay. I've been doing all these demos, all this testing and everything actually in a different environment, and I actually had not thought to do that last final test. Okay, so, stupid bug at the beginning, okay. So Swift objects actually come back to us as Objective-C objects. And I know this because I was like, okay, well, what is the UI app object? UI app, I want to get the delegate. And you get back this crazy type-mangled name. Underscore TTC4 WWDC15 WWDC app delegate. So there is a function called Swift demangle simple class. DLSim RTLD default demangle class simple. It's actually, there's a possibility that this is not actually, they didn't compile this into the, I rely on this function being inside of the app, and I guess this function isn't inside of this, with the name. It's in the app. I happen to know the name of the function, but I don't know the address of the function in memory. But what it does is it's going to take the WWDC and the WWDC app delegate, that's the namespace and the name of the class, and we would just be splitting it out. But the type mangling ends up being that underscore T is just like with underscore Z for C++. And then the C indicates it's a class. If it's a protocol, it's a P. I actually haven't paid enough attention to get the T there yet. And then the 4 is for the length of the string, 15th length of the string, and you get the namespace and the class name. All right. So one of the things that Cycript lets you do is you can ask for fields of a class. So if I do UI app delegate and I do ISA, I will get back the class object from the thing. But I can also just put a star in front of it and pull out the entire thing. And you'll notice this didn't actually work. Actually, my first experience doing this in Cycript is that Cycript entirely crashed, and I was very unhappy. And the reason why is that if you look at the app controller field, I get this assertion that there is no encoding for it. So class get instance variable, pass in this type app controller. That returns that. I do ivar get offset. I find out that it's 16 bytes into the object. I do ivar get type encoding, and I get back null, which makes me very unhappy because that's how I can actually go into the object and figure out what it is. So what I spent now the last 3 days straight nearly doing, and 5 hours until like 3 in the morning last night working on is, well, how do I actually get this type information out of this object? So I can put this down here and balance my computer up a little because I'm typing a lot. All right. So the address of this object. So I'm going to do this. I'm going to get, okay, there's the address right there. I'm going to typecast this in script to a void double pointer. And now, if I were to indirect this, this is going to be the class ISA, the super. So I had the object. I get the first value from it. This is going to be the crash. Which one is that? By the way, and I've not like planned out, like scripted out exactly this demo. So what we're doing is we're like exploring here a little bit as I. And the reason why, yeah, that's of course, because when I did this, I wasn't doing it on the 64-bit device. On the 64-bit device, you have to mask off a bunch of parts of the ISA pointer if you want to be able to do what I just did. So the 64-bit runtime uses some of the high bits and some of the low bits for the reference count of the object stored inline, which is why if I try to just use this as a class, it's going to fail. All right. And I get good. I get to cheat because I can just use app delegate to ISA and get the class pointer, which to then do dot value. That gives me the class pointer. So let's do that, encode that as a void double pointer. And now I'm looking at the Objective-C class object. OK, so this Objective-C class object is also going to have a funny ISA, so I'm not going to try to indirect that. If I go back one, however, so the Objective-C object is laid out in memory, and the Objective-C class object is laid out in memory. One word before that is something called the value witness table, which is a feature specific to Swift. If I go 2 before this, I will actually get a function which I could use to deallocate this object. If I go forward, I'm going to get the normal Objective-C data. So here is the metaclass of this class, the superclass of the class, some cache information, and then I'm going to get the data table for the Objective-C object. The data table for the Objective-C object with Swift uses the low bits. So this bit 1 here indicates that it's a Swift object. And so you can use that in order to figure out whether the object is Swift or not. If I continue forward here, I'm going to go through I'm going to go through 4 32-bit numbers, which is they're showing here as 64-bit numbers because I'm in a 64-bit runtime. I'm going to get the size of the class. I'm going to get a couple flags. I'm going to get the size of this whole structure. But the more important thing is the next one, which is number 7 here. This pointer here is a pointer to the nominal type descriptor. So the very first entry in the vtable slot, so the vtable is stored after the Objective-C metadata, is the nominal type descriptor. So if I now take this pointer here, code it to a void double pointer, and and then go. The very first slot in there are some flags, which happen to be 0 here. If I continue forward a few of these, all right, I believe that is this first one here, which is the name. So if I encode this to a character pointer, this is a really weird thing in script, which I have not fixed yet. DLSim, RTLD default. I'm going to pull strdupe. I'm then going to encode that to a function that returns a character pointer but takes a void pointer. And then I'm going to pass this value into it, and I get the name of the class. All right. So the challenge, however, is what I really want to know is I want to know where all these fields are. So I'm going to continue forward. So I continue forward into here, and this pointer here, which comes after all of those data blocks, that's going to be. There we go. Actually, I guess I'm going to use my strdupe again. So if I strdupe on there, not find strdupe. I didn't actually save my strdupe. There we go. I'm going to get the name of the field. So this pointer is a pointer to a set of null terminated strings for each of the fields in the object. And I know that there's one field because this value here was 1. And I've got a better demonstration of all this, but I really wanted to get to the demo to demonstrate that this actually all works in practice. We'll be able to look at this in the disassembler, and it'll make a little more sense at that point. So, so I've got the right after this string, there would be another string, but we happen to know that this class only has a single field. So the name of the field is app controller. The next thing is particularly interesting because of the way it's used. So this is a function which returns the types of all of the fields. So I'm going to take this and I'm going to typecast it to something that returns a void pointer. And then I'm going to call it. And I'm going to get back now a pointer to the field type table, which gets dynamically allocated and then cached. Now the field type table, I'm going to code that to a void double pointer 0, is going to contain a single pointer to a, what is it called? It's called a type, it's not the direct type metadata, the direct type metadata. And the direct type metadata is the same as when I said before that the Objective-C class object had that extra header and had extra stuff below it, the vtable. That structure is the direct type metadata. So now if I take this and I encode that to a double pointer, this looks like one of these familiar weirdly encoded Objective-C ISAs, actually. And there are 4 bytes. So we are weirdly encoded Objective-C ISA. We've got the cached information. We've got then the size of the class, the size of the table, and then we've got back to that nominal type descriptor, which we're then going to be able to do a void double pointer cast on, pulling null 1, and then we're going to do our strdupe, and we're going to find out that the type of this field is a WWDC application coordinator. So now I know the name of the type, I know the name of the field, I know the type of the field, and the only thing I need now is to figure out the offset of the field. And Objective-C gave that to me, but I don't want to have to rely on Objective-C because I want this to work for all Swift direct type information. So if we go back to the vtable that we were decoding earlier, and we keep going. So that was here, 7, 8, 9, 10, 11, no, 11, 12, 13. I don't know how far we're going to have to go because there's a lot of functions that, a lot of accessor functions, a lot of funny initializer functions. There we go. At the end of the vtable is, that's hopefully the next vtable. At the end of the vtable is a field offset table. And so you can then, what you can do is you take we know the size of the whole structure because that was one of the fields. You skip from the top of the direct type metadata down to the end of the structure, and then the end of the structure is where all of these fields are, and then you can walk back by the number of fields which we got from the nominal type information nominal type descriptor, and then we can walk forward by the field index that we want. And now we know the offset of the field, the type of the field, and the name of the field. And I haven't implemented all of this into Script yet, but the goal is that in the next week or two, you'll be able to use Script in order to introspect on all of the running Swift objects that are inside of a process just as easily as you currently can with Objective-C objects. And with full tab completion, which is the thing that when I was sitting in the console, it was like constantly, I just keep hitting tab and I keep being sad. And in fact, I have already added support for the, I haven't finished, I've already added the parser support for the do something, for with, actually, with is going to do something weird right now, like with values. Oh, did I not compile this? I don't think this is actually the version. I don't think I compiled it. I just added this like this morning. Is the syntax support for the Swift message send syntax, and I'll get that all integrated so you'll be able to tab complete your way through the Swift syntax as easily as you currently can in Script with the Objective-C syntax. Okay, so go over to Hopper. So here we've got the Objective-C class list, which is just a list of pointers to all of the Objective-C class data. If I go here, I happen to know that the first one, which I've annotated here, is the app delegate. So I mentioned that if we go backwards, we see the value witness table, the deallocation function. If we go forward, we have the normal Objective-C metadata, this, the ISA superclass, the cache information, and then the data pointer, which I listed as data never used because that's what Apple calls it. You're never supposed to directly use it. You're supposed to call a function to get the value because it contains extra bits. Then we have the size of the instance. We have I only know this one's a 3 or a 7. We've got the metadata size. We've got this one's 8. Love 8. Nominal type descriptor, vtable, and then as I indicated at the end of the vtable, we have the offsets. And I think I must have been looking at the wrong type when I got the OX10 in the actual on the device, but we got the offsets at the end of this table. So maybe I was looking at the app controller because, of course, I'm just dealing with a large number of void pointers, which is just a really bad way of doing a demo. Okay, so this, however, I actually figured this out more. Oh, it's like this disassembler is going to fail as we go through some of this stuff. And we're going to have to do some math in order to fix it because I figured this out not from analyzing this app and pulling some of this stuff out. Some of it I actually had to kind of figure out by running it and doing things in Script. So, okay, if we go then through to the not the data. Oh my God, I can't even get to them. There we go. What do I want to do? I wanted to go to the nominal type descriptor. Nominal type descriptor has the get field types function. The get field types function I had mentioned, this is clearly not the get field types function, right? So all of these fields are accidentally offset by 4,000. So I did a bunch of math due to the sad way that I had to decode all of this. There we go. There. So here is the get field types function. Get field types function is going to look in the cache, but more importantly then it's going to load the type, which is this offset here, which is also wrong. So we do some more math. That one's right, this one's wrong. 2571G0 there. So we'll then switch to here. This is then the type information for this is the type, what was the name of it? The direct type metadata for the type of the field, and it's got the dealloc function, it's got the value witness table, it's got the Objective-C metadata, it's got the random field, it's got the nominal type descriptor. Nominal type descriptor then has the name, the name is offset wrong, so we take 1E2 DB0, we offset it here, we go there, and we get WWDC application coordinator. Okay, so clearly if anyone has then any low-level questions about how Swift works or is implemented, I might be able to actually answer some of them at this point. Actually, I can't quite see in the audience. Are you the person? Yeah, so I'm really glad that Joe came. I tweeted yesterday saying, like, I'm hanging out in the Marriott lobby working on all of this stuff if anyone would like to come hang out. And Joe spent like 4 hours with me sitting, we were staring at disassembly stuff. I really, really appreciate having company because otherwise I don't think I'd have had the motivation to actually finish this last night. So. Yeah. Any questions? I think I've got like a few minutes at least. Yeah. People are raising their hands.
Hello. Not quite that low level of a question, but so do you happen to know if Swift internally implements, well, like method calls and that sort of thing? Is it done in the same way as
So method
Objective-C?
calls in Swift are implemented in a way very similar to C++. So C++ virtualized objects have a virtual function table pointer as their first field, which then it gets used to look up the function at runtime. And that's what's used in Swift. But they've got different. It's like it's at the end of this data structure. It's like they decided to bridge a C++ vtable with an Objective-C class, and then that turns into Swift. If the type is determinable with certainty at compile time, it will inline the function just like in C++. And so if we go through this code, we'd find examples where we could find the function separate in the vtable, and we'd find it inlined in a call.
And so does it mean you can use all the methods from the Objective-C runtime with Swift objects and do all the nasty stuff with like method swizzling and changing ISA pointers and all that stuff also with Swift objects?
So unfortunately, no. And in fact, actually, I mean, as I had shown at the beginning, the ability to just get the type encoding of an instance variable, they just didn't bother implementing that. And part of the reason you'd imagine is that much like the C++ things in Objective-C, it gets bridged really, like the type encoding mechanism isn't even really designed to support this. Because it's not using the normal Objective-C message send mechanism, it's using the virtual function tables. If you try to swizzle something, you're going to, it's not going to actually affect the behavior. And especially, of course, if the code has been inlined, there would be no way of really making a modification to it. My hope, because I also build this thing called Substrate, which allows developers to make modifications to software. What I'm going to do is I'm going to make it so that you can look up functions more easily, and then you could use the C level, like native hooking functions. It might be able to modify some vtable structure. But there are going to be some situations where the thing just got optimized sufficiently at compile time that the code doesn't even exist.
So it looks like there's still quite a bit of information in the binary compared to like I was worried they were going to strip a lot more than what Objective-C keeps. What other sort of uses could you conjure up with that kind of information, and maybe is worth touching on, I think, Swift modules or something you'd mentioned?
Yes.
Yeah.
Thank you for asking that. So there's still a lot of metadata available inside. In fact, actually, to some extent, I think it's better, more accurate metadata than what the Objective-C runtime provided. There were various cases with bit fields, especially, where the Objective-C runtime from Next was just horribly destructive on all of the information. But one thing, if you compile an application using Xcode, it takes the Swift module and stores in here. So here's the WWDC binary, and here is a segment which is called __ Swift with a section called __ AST, and this thing contains more advanced class level debug information about this about the Swift code, and it's not actually an abstract syntax tree. It's called AST, and you'd think, oh my God, is all of my code in there, and I can just decode it? All the code isn't actually in there. I verified that. As far as changing bodies of functions doesn't cause this block to change. But I haven't spent the time to decode all the information here yet. I was thankful I didn't even need it.
So with Objective-C, normally when you call Objective-C message send or whatever, you send a message to some sort of object or whatever. And with Swift, you can still do selectors and things like that, like this thing perform selector. How does that map? Have you figured out how that maps yet? Because apparently here they don't use messages or anything like that.
So functions which are Objective-C compatible, and that's something where if you mark your class or mark parts of your class with @objc, it'll verify and give you a compiler error if those parts of the class are not Objective-C compatible. Those do get mapped on a best effort basis to the Objective-C runtime, at least read only. So you can still use objc msg send for the things that happen to be compatible on Swift objects. And my understanding is from looking at this stuff is that it does not actually require you to use the @objc keyword in order to get that bridging. The @objc keyword constrains the bridging to make certain that it actually does, you don't screw yourself in a way. Okay, so I think we're currently out of time, but I'm happy to sit around outside and answer questions for however long. So.
In case you weren't here, he's the developer of Cydia, which is the alternative to the App Store for jailbroken iPhones, and he's the creator of Cycript, which is a runtime introspective debugging REPL, which is a hybrid of Objective-C and JavaScript. Jay Freeman.
Can you hear me now? My God, that was loud, actually. Need to talk softer. Okay, so yes, my talk actually didn't even have a title listed until yesterday. There were like a couple different talks that maybe I would be doing, and there were some coordination issues getting that all figured out. With I didn't even understand. It was like a short amount of time that I have, and then with some of the things that Apple announced at WWDC, I clearly know what I'm going to be doing. Bound by the foregoing confidentiality terms for technical information about pre-release Apple software and services disclosed at WWDC. I can't show you the actual tools. I cannot show you screenshots or give you my opinions on whether I like it's really awesome or really horrible or anything. But I can totally tell you what it is and how it affects me and how it affects you. And though, really great, they released an app, the WWDC app, which actually uses Swift inside of it. And that app is public. Anyone can download that app. You can't log into the app unless you have a developer account, but everyone has the app. Cycript allows me to introspect on said app, which means that I can actually now go and use Cycript on that app, and then we can start learning more about Swift and what it does, how it works, etc. I also have the WWDC app open right now in Hopper, which is a disassembler that you can get from the Mac App Store. And I've annotated a few from JavaScript in order to manipulate these arrays. So this actually, I had an Objective-C array that contained 4 and 5. I just sliced it into a JavaScript array that contained an Objective-C 4. Now I can send that JavaScript array object at index 0 as an Objective-C method, and I get back the 4. So I've kind of blurred the object models between Objective-C and JavaScript. So my experience then, while watching the WWDC keynote, as doing all this, is whoa, they just added a objecting console to apps, and that was like one of my #1 features that I like showing people. So the thing I very quickly noticed, though, is that using Swift, they don't have very good tab completion on anything, and so you're trying to introspect into things. It's very difficult to actually utilize it. And so, by the way, yes, I just mentioned something about Swift. Why am I allowed to mention something about Swift? I actually have this little preview thing up that specifically states, in this new agreement, you will not be about what I'm talking about today. So, actually, I need to send script.deb 272.20.10.3. Worked, good. Okay, so what I do is, I do a lot of things, as she described. The thing that I often end up doing demos of at conferences is this thing called Cycript. So Cycript is a JavaScript console. So just like, I can say function return 3, 4, var, y is equal to that. It has syntax highlighting, it has tab completion, and most importantly, it has a bridge to Objective-C. So if I say NS object, I can allocate an NS object. I can send it things. This is going to return the exact same thing I just had. Send things like description. I can use Objective-C syntax for constructing things like arrays. I can then use the syntax of the data structures that I'm going to be messing with. So this is my phone I've SSH'd into. I just installed the new version of Cycript that will hopefully crash less on dealing with this thing. And one thing I really should have done before doing this is verify that this is actually, thank God, okay. I've been doing all these demos, all this testing and everything actually in a different environment, and I actually had not thought to do that last final test. Okay, so, stupid bug at the beginning, okay. So Swift objects actually come back to us as Objective-C objects. And I know this because I was like, okay, well, what is the UI app object? UI app, I want to get the delegate. And you get back this crazy type-mangled name. Underscore TTC4 WWDC 15 WWDC app delegate. So there is a function called Swift